Hello students, today we are going to discuss about biopotential electrodes. So in the previous class we have studied or discussed biopotential signal generation and propagation. How biopotential signals are originated and how it is propagated inside our body. So when you want to diagnose a disease, you have to sense the biosignals and take it to our computer for further processing. So how we are going to sense the biosignals which are present in our body? So as discussed earlier, cell is the basic living structure present in our body. Only due to the presence of cells our body is functioning perfectly. So when a cell is in our resting state, the cell membrane, which is a semi-permeable membrane, allows the movement of potassium and chloride ions inside the cell, and it blocks the movement of potassium ions inside. So due to this nature of semi-permeable membrane, there are more amount of potassium ions and chloride ions present inside the cell membrane and lesser amount of sodium ions inside. Similarly, outside the cell, there are more number of sodium ions and lesser number of potassium ions. So due to this charge imbalance or due to the change in the ionic concentration, a potential is developed across the cell membrane. That potential is called as resting potential, and its average value is between minus 60 millivolts to minus 100 millivolts. The average resting potential value is minus 70 millivolts in a human body. Now, when a cell is excited, the characteristics of the semi-permeable membrane changes. That is, it permits the movement of sodium ions inside and it allows the passage of potassium ions outside. Now after excitation, you will find more number of sodium ions inside the cell and lesser number of sodium ions outside the cell. So due to this ionic difference, the potential changes. So that potential is called as action potential and its average value is plus 20 millivolts. So this potential is called as action potential because the cell generates this potential due to excitation. So our job is to sense the resting potential, action potential. So how it is generated, and we have to take it outside from our body and it has to be taken to the computer. So in this session we will discuss how to read the biosignals, what is their requirement. Okay, so biopotential electrodes. So as discussed earlier, biosignals are generated by cells when they communicate with each other. So each cell generates resting and action potential, and the resting or action potential propagates from one cell to another cell. So due to this propagation, the ions move inside our body, and due to the movement of ions, current flow inside our body. So our job is to measure the flow of current inside our body, which is due to movement of ions. Bioelectrodes. Okay. So in order to measure the ionic flow in our body, there should be some interface to connect the human body to the electronic apparatus for measuring the ionic voltage. Bioelectrodes provide a means of interface between the body and electronics measuring apparatus. Biopotentials, or the resting potential or action potential generated in our body, are called as ionic potentials. So the devices that convert ionic potential into electrical potential are called as electrodes. So bioelectrodes are devices which converts the ionic potential into electronic potential. So the function of bioelectrode is to act as an interface between the biological structures and electronic systems. Okay, so we have to sense the signal from our body and take it to our apparatus. So that job is done by our bioelectrodes. So the biopotential electrodes acts as a transducer to convert the ionic conduction to electronic conduction. So bioelectrodes consist of metal contacts packaged so that they can be easily attached to the skin or other body tissues present in humans. The electrical systems are either passively sensing or actively stimulating electrical potentials within the biological structure or the biological unit. Consider a scenario: a patient is going for checking the cardiovascular system. The first thing done in the hospital will be ECG measurement, so electrocardiogram, recording the heart signals. So for that, they will be fixing some sensor over our chest. So simply they cannot fix the sensors. So over the sensor or over our chest, they will apply a jelly-like substance. Okay, a semi-soluble liquid over the sensor or over the surface of our chest. Then they will fix the sensors. So that jelly-like liquid is called as electrolyte. Okay, so electrolyte represents body fluid containing the ions. So the passage of electric currents from human body to an electrode can be understood by examining the electrode electrolyte interface. So the net current that crosses the interface passing from the electrode to electrolyte consists of electrons moving in a direction opposite to the flow of current, cations moving in the same direction as the movement of electrons, and anions moving in a direction opposite to that of flow of current in an electrolyte. So this is a schematic which represents the movement of ions in an electrode electrolyte interface. So current is passing from left to right, so the electrons will move from right to left. So the electrode consists of metallic ions C. So the electrolyte is an aqueous solution containing cations of the electrode and anions. So at the electrode electrolyte interface, two processes are dominant. One is oxidation and another one is reduction. So oxidation is dominant at the interface when the current is flowing from electrode to electrolyte. The reduction process is dominant when the current flows in the opposite direction. That is, when current flows from electrolyte to electrode. So the oxidation process or reaction causes an atom to lose an electron. So during oxidation, you will lose an electron. Similarly, During the reduction process or reduction reaction, the atom gains electron. So this is happening in the electrode electrolyte interface, oxidation and reduction. So when the metal comes in contact with solution, the electrolyte surrounding the metal is at a different electric potential from rest of the solution. For example, when you apply a jelly like liquid over our chest, all over your chest, you will have a particular value of potential in your body. Now when you place an electrode over a particular point in your on your chest, the potential changes. That particular point potential will be different from, or its value is different from, the potential which is present in other parts of the chest. Okay, so this potential is called as half cell potential. So when a metal comes in contact with an electrolyte solution, the electrolyte surrounding the metal is at a different potential from the rest of the solution. So this potential is called as half cell potential. Okay, so in simple words, the potential developed at electrode electrolyte interface is called as half cell potential. And the half cell potential is determined by certain factors. So what are the factors? First one is metal involved. So what type of metal you used for fabricating the electrodes? Aluminum, platinum, titanium, copper. So based on the type of metals, the half cell potential will vary. Then concentration of ions present in the electrolytic solutions. Okay, so based on the concentration of the ions also, the half cell potential will vary. Then what is the temperature of the measuring region? And other factors like the concentration of other ions. So these are the major factors that determine the presence of half cell potential. Metals involved, concentration of the ions, temperature and the secondary factors. If there is no flow of current in the electrode electrolyte interface, the system will have some fixed value of half cell potential. Okay, so if there is no flow of current, you will have a fixed value of half cell potential. For example, 5 millivolts. If there is a flow of current in the electrode electrolyte interface, the half cell potential value will change. Either it will increase or decrease. Initially, when the current is not flowing, for example, it is at 5 millivolts, and when the current is flowing in the electrode electrolyte interface, it may become 7 volts or it may become 3 volts. So the half cell potential will change. So the difference in the half cell potential is due to polarization of the electrodes. Initially, there was no action, but when you do an action, the cells will get excited and the action potential is produced. That action potential changes the half cell potential in the electrodes. So it causes polarization of the electrodes. So the observed difference between half cell potential and the zero current half cell potential is called as over potential. Okay, so you will have half cell potential when there is no current flow in the cell, and when there is current flow, you will have a different half cell potential. So the difference between the half cell potential when current flows and zero current half cell potential is called as over potential generated by the cell. Okay, so what are the reasons for the over potential generated by the cell? So the half cell potential is altered when there is current flowing in the electrode. So current flow is due to polarization of the electrodes. Over potential is the difference between observed half cell potential with current flow and zero current half cell potential. So the components of over potentials are ohmic over potential, concentration over potential, and action over potential. So we will discuss one by one. So what is over potential? Okay, so all of you know what is ohmic region. So ohmic is nothing but resistive region. Okay, so our human body behaves like a resistor. Okay, so this ohmic over potential is due to the resistance of the electrolyte. When the current passes between two electrodes immersed on the electrolyte, a voltage drop exists along the path of the current in the electrolyte. So the resistance between the electrodes vary as a function of current. Now the voltage drop is directly proportional to the amount of current flowing in the electrodes and the resistivity of the electrolyte. So this voltage drop is called as ohmic over potential, and it is due to the flow of current and the resistivity of the electrolyte. Okay, so ohmic over potential. The second over potential is concentration over potential. So this is due to change in ionic concentration at electrode electrolyte interface. So when the body is in the resting state without any electrolyte, you will have a fixed amount of potential in that place. Now when you apply the electrolyte and place the electrodes, the concentration of ions on that particular region changes. Okay, so due to this concentration mismatch, there is a tendency of the ions to move from one place to another place. Okay, so when the current flows in the electrode, the equilibrium of the particular region is disturbed, or there is no equilibrium present in that particular region. So due to this ionic concentration, the observed concentration potential or the observed half cell potential will be different from the original. So this difference is called as concentration over potential. Third component of over potential is activation over potential. So when there is a current between electrode and the electrolyte, either oxidation or reduction process dominates, and due to that the energy barrier varies and it varies the direction of current flow. So this difference in energy appears as difference in voltage between the electrode and electrolytes. That difference in potential is called as activation over potential. So these three are the reasons for over potential: ohmic drop, concentration over potential, and activation over potential. So the equation which is used to govern the half cell potential is Nernst equation. So based on Nernst equation, the half cell potential is given as when two ionic solutions of different concentration are separated by a semi-permeable membrane, and electric potential exists across the membrane. So that electric potential is called as half cell potential, or simply the potential developed across the electrolyte interface is called as half cell potential. So there are two types of electrodes. So broadly, the electrodes are classified into two types: polarizable electrodes and non-polarizable electrodes. So this classification refers to what happens at the electrode when current passes between electrode and the electrolyte. So based on the flow of current between the electrode and electrolyte, the electrodes are classified as polarizable electrodes and non-polarizable electrodes. But in real time or reality, it is impossible to fabricate these perfect electrodes, either polarizable or non-polarized. So these classifications are in theory only. Practically, it is not possible to achieve perfectly polarizable electrodes and perfectly non-polarizable electrodes. So polarizable electrodes. So no equal charge crosses the electrode-electrolyte interface when current is applied. In reality, current exists, that is current flows, but it is only a displacement current where the electrode behaves like a capacitor. So you know what is displacement. So in practical case, platinum comes close to behaving as perfectly polarizable electrode. The current passing between the electrodes are primarily due to change in the ionic concentration of the interface. The majority of the over potential observed are from concentration over potential. These electrodes show strong capacitive effect. Non-polarizable electrodes. Electrodes in which current passes freely across the electrode-electrolyte interface is called as non-polarizable electrodes. So polarizable means no current passes between electrode and electrolyte. Non-polarizable means current passes freely between electrode and electrolyte interface. It requires no energy to make the transition. That is, electrons does not require any external energy for their movement. So these electrodes does not have any over potential because no energy is required. So these electrodes behaves like resistors. So polarizable electrodes behaves as capacitors, or they have capacitive effect. Non-polarizable electrodes have resistive effect. So the properties of bioelectrodes. So what are the characteristics features of bioelectrodes? So the bioelectrodes or the biopotential electrodes must be good conductors. So our job is to identify or to read the signals present in our body, and the signals which are present inside our body, or the signals which are generated by our body, are very lesser in magnitude. Okay, so the electrodes has to be perfect conductors or good conductors, such that they were able to read the small amount of current flowing inside our body. The electrodes must have low impedance, then only easily current will flow from body to electrodes. They should not polarize when current flows through them. Okay, so the electrodes should not get polarized when current is flowing across it. So they should establish good contact with the body, and it should not cause any motion. So you have to perfectly fix the electrodes over the body, or the electrodes should make fine contact with our body, and during the measurement they should not move. Okay, so the electrodes, next one, the electrodes should not cause itching or swelling or discomfort to the patient. So the electrodes must not create any inconvenience to the patients. So the inconvenience may be due to the type of metals that you use as electrodes. So they should not cause itching, swelling or any type of discomfort to the patient during measurement of the signals. So if patients are not comfortable, the signals which are read by the devices may not be perfect. The metals should not be toxic. So you have to manufacture the biopotential electrodes using materials which are friendly to our human body. Okay. Then the bioelectrodes must be mechanically rugged and easy to clean. Okay, so these are all some of the properties of bioelectrodes. Equivalent circuit of a biopotential electrode. Okay, so each electrode will have a characteristic. So what is the equivalent circuit? So where this electrode is placed is, it is placed in our body using a electrolytic solution. Okay, so this electrode is present between our electrolyte and the metal. Okay, so in between you will have an equivalent circuit. So it has a small potential called as VHA, that is the half cell potential generated. VHA is called as electrode potential or half cell potential developed across the surface. Then C is the charge at the interface of the skin and metal. So the resistance which is present there, RSA, is the electrode electrolyte resistance and the resistance of the surface of our body. It may be skin or muscle or anything. So it is having a potential called as half cell potential, skin resistance or body resistance, and some effect. So if you use two electrodes for the measurement of half cell potential, then you can construct the circuit using an instrumentation amplifier. So the difference between the two electrodes will be measured, amplified, and it will be taken to the unit for further processing. Okay, so the difference in potential will be measured and amplified. Okay, so electrode is a device used to convert the ionic current into electronic current. So electrode is a broad word. Okay, so in real time we will use transducers. Okay, so a transducer is a type of electrode, or a transducer is an electrode used to convert one type of signal to another form. Okay, so transducers are used to measure physiological variables present in our body. So these physiological variables vary with time. Okay, so transducers are used to convert one type of or one form of signal to another form. So this another form is electrical signals. Okay, so the transducers are used to convert physical signals to electrical signals. So the input may be pressure, temperature, etc., and the output is electrical in. So the transducers are classified into two categories. One is active transducer, the other one is passive transducers. So what are active transducers? Okay, so the transducers that are used to convert the known signal to electrical signal is called as active transducer. Okay, so transducers which are used to convert a physical parameter into an electrical signal is called as active transducer. The output will be an electrical signal. But passive transducer It involves control of an excitation voltage or modulation of a carrier signal. Okay, so directly it won't produce an electrical output. It will use a carrier signal, and based on the change in the carrier signal, you can know about the output. So such type of transducers are called as passive transducers. So what are the principles used in transducers? Okay, so based on the classification, so in active transducers that are used to convert electrical signal or any physical signal to an electrical signal, okay, are based on the phenomenons like magnetic induction, piezoelectric effect, thermoelectric effect, and photoelectric effect. So these are the principles used for its operation. Passive transducers. Okay, so this uses principle of controlling a DC excitation or an AC carrier signal. So it consists of a passive circuit element which changes its value as a function of physical variables to be measured. So it cannot convert an electrical signal into a physical variable, or it cannot convert a physical variable into an electrical signal. Example, photoresistor. Okay, photoresistor is a passive circuit transducer. So what are the different types of transducers used in biomedical field? So force transducer, photoelectric displacement transducer, pressure transducers, flow transducers, and transducers with digital output. So all these transducers are used in daily day-to-day practices in hospitals. So force transducers is used in respiratory areas. Photoelectric displacement transducers are used in imaging field. Pressure transducers are used in blood pressure measurements. Flow transducers are used for uh, blood circulation. Okay, so like that, there are different types of transducers used in bio. Okay, so what are the other classifications? Okay, so uh, based on nature of the element used. So first one is resistive transducers. So they are used in measurement of muscle force and stress, that is strain gauge, potentiometers, gamstrers, and respiration, that is thermistors. Okay, so strain gauge, potentiometers, gamstrers, and thermistors. So these are resistive transducers used for measurement in our body. Inductive transducers, LVDT, used for flow measurements, mainly used in muscles. Capacitive transducers, okay, used in the measurement of heart. Photoelectric transducers, used in the measurement of pulse, blood, and oxygen analysis. Piezoelectric transducers, used in the measurement of pulse and ultrasonic blood flow meters. Chemical transducers, used in silver oxide electrodes. Okay, so these are the different types of transducers based on the type of element. So whatever we have discussed till now, they are all broad categories. That is, transducers are classified as active and passive. Then they are classified based on the type of elements used. Now, what are all the types of biomedical electrodes which are practically used in the hospitals? Okay, so type of biopotential electrodes really used in hospitals. So there are four major classification. The first one is called as surface electrode, second one is micro electrode, third one is called as internal electrode, and fourth one is called as needle electrodes. So surface electrodes, micro electrodes, internal electrodes, and needle electrodes. So these are the four different types of electrodes used in biomedical instrumentation or medical